All right, let's dive straight into this explainer. Today, we're analyzing the physiology and agronomic management of modern intensive Carob cultivation. Specifically, we're looking at the species Ceratonia silica. We have a 3-year-old orchard here, currently active in its autumn flowering phase. Our main technical objective with a system like this? Rapidly accelerating the plant's entry into commercial production through strict physiological management.
Just looking at the biological baseline, it's actually incredibly impressive. At just 3 years post-transplant, this plant is already exhibiting exceptional structural ramification while actively flowering. With the right nursery innovations paired with highly precise field management, we can completely bypass that traditional vegetative delay. We're pushing the plant directly into early yield, and it's all about establishing a functional vegetative-productive balance right out of the gate.
So, here is our roadmap for today's physiological breakdown. We'll be covering planting parameters and objectives, soil structure and irrigation, canopy architecture, reproductive physiology and varieties, and finally, sustainability and productivity.
Let's start right off with Section 1, Planting Parameters and Objectives.
We're looking at a planting distance of 6 by 5 meters, which gives us a high-density layout of about 330 plants per hectare. From a strictly physiological standpoint, this is a massive shift away from traditional, low-density carob orchards. Why go this tight? Well, this specific spatial configuration rapidly accelerates how fast we occupy productive space. But most importantly, it maximizes the overall photosynthetic efficiency of the orchard per square meter of land. By closing the row spacing efficiently, we lock in optimal light interception early in the orchard's life cycle, and we do this without creating that severe intra-canopy shading that would eventually compromise our fruiting wood.
Moving on to Section 2, Soil Structure and Irrigation. Now, physical soil interventions are absolutely critical here. Sure, the carob is famously adaptable to poor, stony, and calcareous soils, but its root system, it is extremely sensitive to asphyxia and water stagnation. So the solution is physical elevation, a light soil ridging, widely known in the field as a balatura. Honestly, this is an absolute agronomic mandate in these types of soils. By raising the planting line, we guarantee rapid water drainage, preventing lethal physiological stress and root disease when those heavy precipitation events hit. And as you can see, we pair this with double-drip irrigation lines to tightly control our moisture levels.
Speaking of moisture, our irrigation inputs sit right around 2,000 to 3,000 cubic meters per hectare per year. Yes, the carob is highly resilient to drought, but relying on purely rain-fed strategies will severely delay physiological maturity. Controlled water inputs via those double drip lines ensure an early vegetative balance. The plant gets exactly the hydration it requires to build its structural framework in the first 2 years. We're setting the stage for early fruiting without pushing the tree into excessive, non-productive vigor. Let's transition over to Section 3, Canopy Architecture. It's fascinating to trace the physiological cause and effect of our structural pruning here. Following the applied methodologies of agronomist Vito Vitelli, we make a deliberate head cut right at 70 to 80 centimeters. This instantly breaks the plant's natural apical dominance. Then, rather than severely thinning down to just 3 branches, we actually allow 5 to 6 primary branches to develop. Why? Because this triggers intense interbranch competition for light and nutrients, which naturally dials back the excessive vegetative vigor of each individual branch. The direct physiological response is that energy is shifted away from vertical wood production, heavily stimulating the creation of reproductive fruiting wood on the lower portions of the canopy.
Now for Section 4, Reproductive Physiology and Varieties.
Traditional orchards relied heavily on dioecious plants. This meant you had to plant separate, non-producing male trees purely for pollination. Talk about a wasted spatial footprint, right? Modern high-density systems solve this by utilizing hermaphrodite varieties. Because these specific genetics possess both functional male and female floral organs, they are entirely self-pollinating. That means every single tree in our 6x5 grid operates as a fully productive unit. It fundamentally upgrades the spatial efficiency of the orchard and guarantees a much higher continuity of production.
Let's look at the flowering cycle. The carob has a really unique autumn flowering phase that peaks roughly between October and November. The plant sets a small fruit that overwinters before swelling up in the spring. This highly specific phenological trait means the crop is perfectly adapted to a mild, coastal, Mediterranean macroclimate. But to ensure optimal fruit set and avoid the physiological stress that leads to flower drop, the system requires environments that are completely free from severe winter chill. It's a highly efficient physiological adaptation to these coastal zones.
Finally, we reach Section 5, Sustainability and Productivity.
When we structurally manage the wood properly, it allows these large carob pods to cluster heavily. This maximizes light exposure and provides direct photosynthetic support straight to the fruit. And these agronomic outputs? They feed right into incredibly lucrative global supply chains. We select varieties for high seed yield, supplying natural thickening gums that are absolutely crucial for the international confectionery and cosmetics industries. At the same time, the pod pulp meets a massive and growing demand in the vegan nutrition space as a sustainable food alternative. It's a textbook example of agronomic efficiency in the field perfectly servicing highly stable industrial demand.
And that all comes together in the concept of the albero libero, or free tree. Peak system efficiency is achieved through an optimal vegetative productive balance. Those initial structural cuts break the apical dominance, maximize our light interception, and establish a canopy that requires drastically reduced annual pruning. Ultimately, intensive agronomic success is strictly a function of aligning your physical management with the plant's natural physiological tendencies. The result is long-term stable productivity, reduced manual labor cost, and a highly illuminated, biologically efficient canopy. Really makes you rethink what is possible with modern orchard architecture, doesn't it?